Okay, this is asynchronous work for PreCalc, both regular and honors. And this is a topic, chapter 4-6, assignment 47. And the section is example 5 and example 6, I believe. It's called damped trigonometric graphs. So you can graph the product of the two functions using properties of individual functions. For instance, consider function f of x equal to x sine x. When we talk about this, we have to think about boundaries, and I will explain boundaries at the beginning. Okay, boundaries are if you you learn this process as if you write down the sine function. And a difference of D, right? So if you think about D, it's going to be 7 is a midline. So I don't know where 7 is, just I create the 7 here. Maybe one unit is 2, 2, 2, 2, and 7 might be between the third line and fourth line. This is y equals 7. Now you have to think about is the boundary goes to +2 and -2. That's the amplitude is 2, right? So I write down it's 2 here. Oh, I think I have enough units. So let me see. So if you consider one is let me lock this one. So 1, 2, 3, 4, 5, 6, 7. So y equals 7 is a midline, and go up 2 and go down 2. So that is the boundary. So I can grab this. Right, so these are boundaries. Okay, so if you remember how to write down cosine function, if it's positive, it goes to if the b equal 1, so it must be 2 pi. So if you consider this is let's see, let me use the crayon too. Do quick, sorry. So you can divide by 1, 2, 3, 4. If this is a pi here, I put pi here. Maybe I can use the same graph for later. So pi here, right? Wait a minute. 2 pi over b, so this must be 2 pi, sorry. It's too late, it's 2 o'clock in the morning. So this is 2 pi. So I make it a little smaller. Half of this is going to be pi here, pi. Okay? Now, half of this value is pi over 2. And between those two is those. Okay, if it's your honors, you just finished test, so this one was included, right? If you are a regular class, you're after spring break, you're gonna have test about this, so you learn from here. Now, this is sine graph. Sine usually graph start from 0, however, shifted to up to 7 here. So this is going to start here, and normally goes to go this direction. However, it goes to, since it's negative, start to reverse the direction. So let me, I use this one. And those are turning points, maybe the critical points, right? So it goes to here. Oh, it's not white. It is smaller. That is red. So it goes to this direction. Go back to 0 when you hit the pi, and go to max when you hit the pi over 3, and go back to the midline here. Sorry, my graphing technique is not that happening. So go like this, yeah. you will hit this edge here, okay? So this is one cycle, right? So boundary is here. It's going to be 7 plus 2, which is 9, and 7 minus 2, which is 5, right? Those are called boundaries, okay? So if you go up and down, so there is no, it's called damping is not happening here because it's the parallel lines, okay? Now let's think about this one. Next one is think about this one. If this is the number of the midline and it goes up and down is a period here, right? Plus minus goes up. So how about this? Well, you see, generalize what you see on the question one. So B is the boundary. So B, not the B, is the midline. Midline plus minus A is going to be, so if I generalize, I use this one. Oh, but what's this? It's not 7 plus minus X actually, 7 plus minus 2. Thank you. Right? That's the boundary. So 7 plus 2 is 9, and 7 minus 2 is 5. That's why there's a boundary. How about here? So if this is the equation here, now equation is a variable here. So you can generalize, no? So I come and paste here. Come and paste here. Same way. So B is going to be this midline. From the midline, you can go up and down. How many go up and down? That's amplitude, which is A. So B plus minus A. Yeah. Now, here, how about this? So negative 4 is going to be midline plus minus X. Now, if you see this, negative 4 plus X and negative 4 minus X, those are the linear function, right? Now, so same thing here. Now it's a little bit reverse. X plus minus 4. So now I notice I was hiding the flashcard style. So you don't have to do this. So now this is number 3, number 4. This is the boundary. Now you know the boundary is. So let's go to this question. Now it's damping. Damping is kind of moisture, musty, a little bit wet, right, in the air. So it's not really wet, but it's right between wet and dry. Now, that's damping. But on the sound, it means quieter. Okay, so now, if you think about this in the same way, the midline is where? 0. And maybe I cut and paste here. Midline is 0 plus minus X. Plus minus X. So, what do you see here? One of the answer is X, which is, one of the answer is X, and the other answer is negative X. So let me write down, comma, negative X. All right, if you come up this answer, let's think about this little bit line here. This is, as you notice on your Algebra 1 class, maybe before pre-algebra class, you learn this line, dotted line. Maybe I should make a solid line, maybe, because I make it a solid line. This thing, maybe I would change a little color here to a little bit grayish color. Okay, this might be x plus 1. I'm sorry. Y equal x. I'm sorry. It's too late for me. Right now, What did I do? I tried to make this line. All right. So I will make x equal negative, y equal negative x. So this is a line I made here, okay? I wonder how it will affect it here. Now, if I plug in 0 here, sine equals 0, so 0 times 0 is 0, okay? And I said I will use these numbers, right? So I will use these numbers, or these x coordinates to right here. I should have made it a little bigger, so maybe I make it a little bigger here. Okay, now I will cut and paste those information. Now I put, so I put 0 here, right? Okay, maybe 2 units each. So if you see 2 units, you see 2 pi ends here. Okay, now I have to enter those data. I have to make cut and paste here to here. Start from 0, but x goes to 2 pi. Pi, I'm sorry, 2 pi goes somewhere else. First, start from this number. 0, half pi, and pi, 3. The reason why I plug in those numbers, because it might be easy to find out here what the sign of x. Okay, sign of 0 is 0, this is 1. So it must be the same amount of this number. Oh, it disappeared. More. Okay. Now, this number, the sign of x is 1. So you just plug in this one to 1. I wonder if they accept this. Let's see. Okay. Now, this number, 180 degree, right? So it's going to be 0. So this comes back to 0. Okay. What else is 0? So this is going to be 0 here. All right. How about this number? This is negative 1. And negative 1 times this one is going to be, I'm sorry, negative 1 here. And times this one, what I'm doing here. I should write down the product here, right? Sorry. So this is the product here. And this should be 1 and negative 1. So this value, if I can grab this, I can't grab this, so let me grab here. This grab here, it's a group. Okay, now this value becomes negative. Negative. Okay, the one thing here I do here. Now this is the number, these are two numbers only come out nice product, and of course this is a nice product, but product is 0. Now when you look at this, the product is kind of y product, right? So y is a product, so product equal to y. This, and one thing you notice is on the coordinates, on the y coordinates here, become the same amount of this, right? But it's going to be sometimes reverse, sometimes it's okay. So I will put this one here. pi over 2, first line, let me see, and pi here, 2 up, pi over 3 pi over 2 is going to be right here, because it's going to be a product here, and 2 units up is going to be where it's hard to see here. Here, might be here, 2, 2, 2, 2. Okay, so this right here is going to be right here. Now, this x, so let's point this 0, 0, 0. This is a product of y. So y equals 0 is right here, right? So when is it 0, 0 here? Pi is 0, 2 pi is 0. So now you see the first number is pi over 2, which is 1. So it's the product pi over 2, pi over 2. So it must be here. Now, go back to 0. 3 pi over 2, negative 3 pi over 2. So when you hit this, oh, it goes to this direction. So it's going to be 1, 2, 3, which is here. Now what do you see? Go here, here, and come back to 2 pi equals 0, right? So it goes here. Now, most likely, if you hit here, it goes here. So you will go to a bigger and bigger damping list, just like this. Now, this is going to be symmetry over y-axis, right? So it's going to be start from here, and when you hit here, you will hit here. Go here, and go into 0, 2 units after. So 2 units after is here. And 2 units after, it's going to be hit here. And 2 units after, you're going to hit here. So that's why I made that line like this, okay? So, so when you look at this right here, this is next question here. So look at the right here. This is what the textbook showing. Okay. Now next question is a little tougher because I wonder if how many of you remember what natural number e is. E to the first power is this one. But now f of x equals e to the exponential function negative x, e to x, actually e to the x power, I just plug in this one. E to the 0th power is 1, right? Now, if you remember negative first power, it's going to be 1 over e. It's going to be like this. So where do you look at it? So when you hit negative 1, the first number is e. So if it's 0th power, it's going to be 1. So this become, oh, this is what I'm doing. This is, oh yeah, this is e to the positive. So if you plug in here, let me get that. Let me clean up here. If you go here, e is, where is e? It's going to be, where's e? Can you see it? Highlight section right here. E to x bar, so x is this one. If it's plugging positive x, and if you graph, something else came up. So this is, let me turn this one off. Let me go to the graph again. So this is going to be, it's a little cut off, but this is the equation. Now, if you plug in negative value there, let me go here and let me change the window. So this is what exactly this is. This is f of x equal f of x equal to e to positive x power. This was a graph. Now, but your question is slightly different. Your question is negative x power, okay? And you have to still multiply this function, sine 3x, okay? So first, let's think about this one with a negative value. So it must be the mirror image, and also if this is a function here, what is the boundary, right? So plug in here. Now, this graph is going to be slightly different. Now, let me enter this. Y equal e to negative x where here x, okay? It might be hard for you to see, but this, I enter the data and I put this one has a negative, maybe negative 10 for the minimum value. X equal maybe around here. Y value might be around 20 maybe. Okay, let me enter this graph. Now you see this going this direction? Now, this is going to be, it looks like it's touching to the y-axis, but it's not. This is asymptotes. This is the value right here. However, what the first question is, what's the boundary? Boundary is midline. Midline is what for this function? Midline is 0. And you have to go to plus minus this, right? So let me write down. The boundary is boundary. Bound, not constant. Bound is bound is right spelling. What did I do in my spelling? This is ES. Let me get the boundaries here. Let me go back to that page. I'm doing it. So I'm a little bit disappointed. Slow. Okay, boundaries. Now, midline is x equals 0. Oh, I'm sorry. Y equals 0. So boundary must be 0 plus this value and 0 minus this value, right? So boundaries, I should write down the boundaries here, is 0. Go to this cut and paste here. 0 plus minus e to the negative x bar, which is, if I can do well on this activity, I will create this one mirror image or flip up and down maybe. Yeah. Now, think about this is like a trumpet here, because this is supposed to be asymptotes here. Going like this, oh, it's not kind enough. All right, so if it's the real world scenario, this is x-axis, and this one's supposed to come asymptotes, which is going this direction, okay? And this direction. So I will change this color to blue, because this is showing the blue as an indication, okay? Now change the color blue, right? So this is what the boundaries for e to negative x power. Now, so I tell you, so if you create the sine value here, so it's going to be bouncing up down here. That's why it's the damping is become quieter. The sound become quieter. See? So I don't know where to assign this number to start, but most likely it goes like this and going down to this. Okay, so let's see if you can see the view of your textbook right here. See? Okay, so this is how it happens. If you have any questions, let me know. And during the break, I'm here. I can log in. Anyway, so this is the for your weekend music, and I don't know what to play. Let's see. Spring song. Anything spring song? Oh, there's a song called, let's see, April in Paris. If I can play it, let's see. Have a nice spring break.